Time, it's always there. We live in it. From the moment we wake up to the moment we fall asleep, time is our constant companion. We experience it every second. Each tick of the clock, each grain of sand falling through the hourglass, marks the passage of time. But what is it really? Time is a mystery. Scientists and philosophers alike have pondered its nature for centuries. It's a fundamental aspect of the universe. From the vast galaxies to the smallest particles, everything is governed by time. We can't see it, touch it, or hold it. Yet, its presence is undeniable. Yet, we feel its relentless march. Days turn into nights, seasons change, and life moves forward. Time gives order to our lives. It structures our days, our weeks, our years. It separates past, present, and future. It allows us to reflect on what has been and to plan for what will be. It allows us to remember yesterday, we experience today. Each moment becomes a memory, a part of our personal history. We dream of tomorrow, all thanks to the passage of time. Our hopes and aspirations are tied to the future, but despite its familiarity, time remains one of the most profound enigmas in science and philosophy. Its true nature continues to elude us, inviting endless exploration and contemplation. Since ancient times, humans have tried to understand time. We built sundials, tracking the sun's shadow. Water clocks measured time with steady drips. Eventually, we developed mechanical clocks and watches. These inventions allowed for increasingly precise measurements of time. They brought structure to our days and societies, but they didn't answer the fundamental question, what is time? The answer lay in the realm of physics. Albert Einstein revolutionized our understanding of time. His groundbreaking work in the early 20th century changed the way we perceive the universe. His theory of relativity proposed a radical idea: time is not absolute. Instead, it is intertwined with the fabric of space itself, forming what we now call space-time. It's relative, meaning it can change depending on speed and gravity. The faster you move, the slower time passes for you compared to someone who is stationary. Imagine this. Time flows slower for objects moving incredibly fast. This phenomenon is known as time dilation, and has been confirmed through various experiments. It also slows down near massive objects like black holes due to their immense gravity. The stronger the gravitational field, the more pronounced the effect on time. This mind-bending concept has been experimentally proven. Atomic clocks, the most precise timekeeping devices, have shown that time ticks differently at varying altitudes and speeds. It has profound implications for our understanding of the cosmos. From the behavior of galaxies to the life cycle of stars, the relativity of time shapes the very structure of our universe. Einstein's theories opened up fascinating possibilities. Could we manipulate time, perhaps even travel through it? The concept of wormholes emerged, theoretical tunnels connecting distant points in space-time. If traversable, wormholes could potentially allow for shortcuts through time. However, the existence of wormholes remains theoretical. The technology to create or manipulate them, if they do exist, is far beyond our current capabilities. Time plays a crucial role in the grand story of the universe. It is the silent witness to the birth and death of stars, the formation of galaxies, and the evolution of life itself. The Big Bang, the event that birthed our universe, marked the beginning of time as we know it. In an instant, a singularity exploded, giving rise to all matter and energy. From that moment, space and time have been expanding. Galaxies drift apart, and the universe continues to stretch, creating more space and more time. On the other end of the cosmic spectrum are black holes. These regions of space are where gravity is so strong that nothing, not even light, can escape their pull. These enigmatic objects warp time dramatically. As you approach a black hole, time slows down relative to an outside observer. At their event horizon, the boundary beyond which nothing can escape, time essentially stands still from our perspective. This boundary is a point of no return. Time then is not merely a way to measure the ticking of clocks. It is a fundamental aspect of our universe, influencing everything from the smallest particles to the largest structures. It's woven into the very fabric of the universe. Space and time are intertwined, creating the four-dimensional continuum known as space-time. It's a dimension just as real as space itself. Understanding time helps us unlock the mysteries of the cosmos, from the Big Bang to the enigmatic black holes.